All right. Looks like we have a quorum. Let's go ahead and get started. Rao, are you ready to give the technical update?
Yes, I am. Let me share my screen. I posted the link to the latest community update 147 in the chat, and I think you should be seeing my screen now. So here is community update 147. All the mainnet nodes are now running 09.25.7. This I spoke about last week. It's a bug fix release with fixes for the data corruption that was happening in LMDB occasionally. And the 09.26 for what I'm calling the for now final release is coming through soon. And today we have a presentation by Tomislav on that work and a demo. And also we have a presentation by Raphael on his updates to the Dappy and other things that he's working on using RChain. So that's where we are. Testnet has been running 09.25.7 for a little while, so nothing changed there. So the focus right now is the 09.26 work is almost complete, and Tomislav will speak to that today. But there has been substantial work going on the block merge branch, and separately, Roland 1.1 branch. Joe has been working on that. Those are the main parts of focus for where we are with the development activity right now. On block merge, NutZipper has started combining his stream of work with Will's stream of work. So Will was focusing on the resolution of the conflicts, and NutZipper was focusing on the merging part. So now they're bringing it together, and there's still more work to be done there, obviously, but they're making good progress. And most of the dependencies have been updated. There's still some more. When we do there is a task that we have had on the back burner for a while to improve the monitoring framework so that devs can quickly get to the bottom of the issues and are able to correlate what's going on the network with the logs, with the state that they're seeing. So there are improvements that we're going to do to the InfluxDB, KMon, Zipkin, that whole set of things that we use. And when we do that, there'll be some more dependency updates, and that'll be included as part of that. And I think there's also a look into the logging framework, as we're using Scala logging currently, and I think Tomislav is looking at something that's much better than Scala. I think it's called Scribe Async. So that's also part of that mix when we get to that task on improving the monitoring framework. And basically, this will help us identify the sources of errors relatively quickly, and should help programmer productivity quite a bit with that. So on Roland 1.1, Joe has made very nice progress. He has completed the spec clarification process for now anyways. And he is getting ready to release the first PR that deals with the send, receive, and let syntax portions of the spec. So he's got some tests to write and a bunch of other things around it, but at least we're getting there to that first PR. And that will set us up for dealing with the 4 comprehension changes eventually. So that's kind of where we are. I spoke to a whole bunch of other things that need to happen to get Roland 1.1 in actual production or deployment on the mainnet. I won't take too much time on that this time, but I will revisit that set of actions that we need to do as we get closer to the Roland 1.1 getting to a stage where we can use it. The Dazzle contract would be one of the first places where we would use the Rolang 1.14 comprehension. And Gurinder has been working diligently on reducing we're currently running a little over budget on the servers. So he's looking at rationalizing the use of the resources to see how we can reduce that budget and also hopefully create more nodes that we may be able to deploy on the mainnet. So that is where we are with all of that. I think on the rest of that, there has not been anything significant that we need to speak to on the APIs and all that. So with that, I want to turn the floor over to Greg so we can go on with the demos. Are there any questions on any of this? There's one other thing I wanted to mention. There was, I guess, some questions in the community as to, what's really going on with Last Finalized State? Why is it delayed, quote unquote delayed? I just want to remind the community that the core of the Last Finalized State was delivered back between August 27th and September 17th. So what has been taking a long time, really, because the Last Finalized State is a very critical change, meaning if you get anything wrong there, you'll screw up the whole state of the blockchain and the integrity of the blockchain. So for that reason, we have been taking our time testing it under various different conditions. And I wrote a fairly detailed explanation of all of that in the members channel. So please feel free to read that. But also you will get a sense of what all was involved from Tomislav's demo today. So I just wanted to make that point and answer any questions that anybody might have. All right, over to you, Greg.
Great, thank you, Ra. I appreciate it. Yeah, so what we want to do now is we have two demos. So we'll go with Tomislav and then Raphael, and then after that we'll do the community and review. Tomislav, are you ready?
Yes, I'm ready.
Okay.
So, hello everyone. I'm so happy that I can finally say that Last Finalized State is like almost finished. With saying that, I also must say that we have one little bug that bothers us like pretty long time, and it's still not resolved. I will say more about that later. So I also have some slides, but first I want to start from the main point, how to run the node with Last Finalized State. So I'm still not completely finished with the whole setup and all the instructions and everything, but most of the stuff is I already have it tested, and I'm probably tomorrow I will have like most of this done. What I want to do now is start the node on the Headset Cloud, which is very similar to DigitalOcean. So I prepared some initialization scripts, and I will choose this one to set up all the dependency on the machine and also to start the node. So I will choose the server. For example, this one with 16 CPUs and 32 gigabytes, and this is like pretty strong machine. Here is the user data or initialization that can be specified when you are starting your machine, and similarly this works on DigitalOcean. I will choose my SSH key of my machine, and I will say the name of the machine. So we can see that machine started, and do I see the graphs? Oh, it's not available yet. So here is a diagnostic software for JVM that we can see a CPU and the memory. And I will show here when the node connects. So this is the source node from which we will request the state, and blocks will be requested for all the other nodes. So I will jump to the slides until machine is started, and I will show how this works. Please help me with questions. It will be like easier for me if you have, and if something is not clear. I want to start from the mainnet launch, which was at winter, and we fixed lots of problems. And for me, it was amazing that we succeeded, and because I was pretty new to Scala, and fixing bugs was definitely something that I didn't know that I can really do it. So, so this is like some of the things that that we finished or working on. And for example, cost accounting was almost finished, and some of the stuff in the related to proof of stake and Genesis ceremony, it was not completely done. So we finalized that and tested, and also some of the improvements in the API or how users can get the block information, and or Ethereum support for Ethereum signature and this kind of stuff. Yeah, one of the things in the proof of stake was conflicts. That was something that stop us to release mainnet. Also, bugs in RSpace. I put asterisk here because we didn't resolve everything immediately. So and also the memory and CPU problems, we made it under control, but I will show you that we still have some problems with memory and CPU. I hope that the RSpace bugs are finally resolved. And there is some more things. It is like the whole list, but so and we also made some compromises so that we can start the mainnet. And for example, we noticed that existing support for multi-parent Casper was slower than just running single parent. So this is why we're still running single parent, and we will enable multi-parent when block merge will be done. So and also, as I mentioned, the RSpace bugs, some of the bugs were still present, and we know that we had one slashing node, and this was Theo's node without, I mean, it was not his fault. It was just the error in the reading from LNDB database, and node created the wrong block. I hope that we finally resolved the last bug in RSpace. Or with LNDB. So for now, we didn't see anything like that, but yeah, I think it's the last one. This problems with the memory and CPU spike. I think this was the main reason why Last Finalized State is also prolonged, because we tried to find out what is the cause, and also that was causing us problems with corruption in the databases, especially block storage, because it was based on the file, and when writing to the file, when node crashed, we seen the corruption, and it was like really hard to restore the database, and this is something that Gurinder is fighting constantly. So I hope that with last finalized state we will resolve this. And also one of the things is that we had high memory usage, which was also something that doesn't go along with last finalized state and parallelization. So that was like a big part of the work to find out where the memory is used and how to reduce it. I will show that now we have a much better situation. So for what do we really need for last finalized state? What this means? The main thing is the rolling state. This is basically the whole state of the network is in the rolling state, and this means that the most important stuff is proof of stake state with the bonds, validators, slashing, and all the related stuff, and of course the other system contracts like revolts, registry, and all the user contracts. So this is the part that we need to download as a part of last finalized state, and also some of the blocks. And what does it mean, some of the blocks? First, we need to start from some point in the history, and this is the last finalized block. I mean, we can use any finalized block, but if we want to latest state, this is the last finalized block. And we also call this approved block. And the genesis, for example, is the first approved block. And from this block, we are taking the state that is associated with this block. And to continue replaying new blocks, we also need some older blocks than finalized block. And what this means is, for each validator we take the latest block that is this validator is produced, and we take the oldest one, and this is the minimum block that we need to acquire. Normally, this is very small amount of blocks because we have another requirement, 50 blocks to validate the deploys. So around this amount of blocks we need to last finalized state. But I must say that because we have some, we made some compromises in mainnet, and we have slashed validator, and this validator latest message is still part of the consensus, because this validator is still active validator, although it's not producing blocks, but in POS it's still part of the calculation of consensus. So we need to take this validator also into account and his latest blocks. So this is why we are downloading much larger amount of blocks. This will be resolved with the next epoch change, or changing the proof of stake contract. So probably epoch change will happen first, but after the block merge, this is the first next step that we will work on. So now I want to say, what does it mean, rolling state? I just want to shortly explain what was the work, like the first thing that was needed for last finalized state, and this is how to transfer the one state of the R space, and I'm saying one state because with each block we are saving like snapshot of the state. We are saving the snapshot of the state after processing each block. So we with last finalized state, we are taking one of this snapshot, and we need to transfer it through the network in chunks, right? Because the whole state right now is around 20 gigabytes. So we need to split it in a sequence of bytes and transfer it over the network. And R space really means equal to rolling. So rolling state is basically written in the R space. And to have the state consistent, Merkle tree is used to store this like one snapshot. Also, we are calling this the history, because with each snapshot represents like one point in the history. And so one of the first things that we were working on is how to traverse this tri-state, this tree, and serialize it into chunks, and also to be able to validate it after it's received. And this basically just means how we are storing maps. And maps, I mean like key value structure. And it's stored basically in this way, where each key is split into bytes, and we are using keys of 32 bytes, and by the prefix of this key, the path is created in this tree, and basically the data for each key is written on the leaves on the each path, and how data are transferred now is starting from the root, where we have we know the order of all of the nodes, and we can with depth first traversal, we can specify how many elements from this tree we want to how many elements we want to get and package up in this chunk for transfer. So another part is blocks. So this part of the rolling state and traversal, that was the first, and that was the first that we did, and it was basically finished very early. But after that, the problems with the blocks and how we are requesting blocks was also the problem, because as I mentioned, the DAG storage and the block storage was based on the file. So file was appended with the data, and extending this was very problematic. So and basically, first I want to explain what does it mean to have this DAG, or what in Arnold what this represents. So with the blocks, this is like the raw data, all of the changes to the rolling state. And block DAG and the DAG storage is basically when we process the block and apply the changes, apply the Casper consensus and all of the validations, we then create this DAG representation. So from the sequence of blocks, we have some structure how they are connected, and we can also decide which block is invalid, which is orphaned, which is valid. And basically it can be seen as a optimization to not process block all the time, right? We process some amount of blocks, and we came to some state, and in the DAG we basically have all of the processing results that all the processing results that we get from blocks. And for last finalized state, we need to add blocks to the DAG, and that was the problem with the file storage. So one of the reasons so let me first say some of the problems. So DAG storage was assuming that we have only one single genesis block, the first one. So now with last finalized state, we need to be able to download any finalized block and all of the logic should behave in the same way as we have the first Genesis block. Another problem was single access. So this file was always taking the lock for each call, and all the requests needed to wait until this lock is free. And this was like very slow, and with Last Finalized State, again, this was the major problem. And also I mentioned that with file-based storage, every crash that we have was potential to corrupt the database. And then we would need to copy the database from some other node, which is time consuming, and with a bigger database, this is like much harder. And now this is especially harder with Gurinder is saying that we have 400 gigabytes for the database, and this is like very, very difficult to copy and to manage. And and we are already using LNDB for our space, so it was like reasonable to use LNDB for all the other stuff, and because LNDB is guaranteeing some consistency. So this is why we started to work on a redesign of key value store, or make some abstractions that is easier to use or easy to reuse in multiple places, and also to easier to manage when to split managing resources, or how this key value store is implemented, and on the places where this is used. So now we can more easily implement key value store with different databases. For example, with the problem with the corruption of database, I really didn't know where is the error. So in that attempt, I also tried to use RocksDB as just to see if I can diagnose error more easily. So just this ad hoc implementation was pretty easy. So now we can think about trying different databases, and maybe use different databases inside the node together. If we see that for block storage, for example, some other database is faster than, for example, for our space. I mentioned here that block store was not initially, we were not thinking to migrate to LNDB, because it was a little harder, but with all the other problems for Last Finalized State, at the end, I decided to move Blockstar also to LNDB. So, but this is also a good thing, because now with starting from scratch with Last Finalized State, this will be the default database, and now we have also compression, so even less space we need to use. This new key value store abstraction we also already using as a cache for Casper buffer or for reporting, and we are planning to use it for RSpace and deploy storage, or for any other storage, and also to add some layer above that, so we can have some kind of notion of a normal database that we can query and get some results, because now we're pretty much closed, and that was one of the problems to diagnose what's happening inside the RNet. So because we have a slashed validator with latest message way in the past, we are downloading almost 200,000 blocks, and that become a problem with the code that we had. So for this purpose of Last Finalized State, we also decided to rewrite this part of the logic separately, to not change existing code, and that was like the easiest way to download the blocks and still have existing logic unchanged. Also, download of these blocks show that we have some very small memory leak, but consistent memory leak in the transport layer. We will see if this is now resolved in the last finalized state branch, and now it is going to be merged on the deb branch. So we will see if maybe we can relate these two problems that we see in the validators node. We try to another memory leak that we have on the heap. This is native memory. On the heap we have this another memory leak, which is still present. And today on node 6 validator had the same situation. And usually we see that when there are some networking errors. So we are debugging this how this happens. We try to update the whole stack, which was also big part of the work, because in the last 2 years this was not updated, and there was lots of changes. We have custom code, and even that didn't help. I see some improvements, but the bug didn't resolve with that. So this is why I put asterisk here, because we still need more investigation. And this is how this looks like. Node is starting normally, but after some period or some usually this is the network errors. It's starting to behave like very strange. Memory just jump, CPU sometimes jump, sometimes can be very low, but at the end node is crashing with out of memory error. Sometimes node can also survive this kind of behavior, but this is very rarely. And this is from today what happened on the validator node. So this is still very much something that doesn't give me sleep normally. So I must also say that one other thing was problematic, and something that should be like very simple, but we noticed that this history tree that where we are storing rspace, we can check for consistency from root hash until all of the leaves. So each node have the hash, the hash or the key that this node represents is basically the hash of all of the child nodes. This is not done completely in this way. So basically what this means is we cannot just take the value that we receive and check the hash. We also need to do some additional encoding, decoding of the values. And this part is basically just prolonging the receiving of the state. I was trying hard to push this to CPU so that this is not so visible. So now basically means stronger machine will get to the state faster. We can optimize this. I think we can optimize this a little, but until we completely fix this bug, this will be like current situation. So I want to show some of the testing results. For example, and what I said for CPU, this is basically it. Node is just validating the state, saving, and this should be like not too much CPU intensive. But because this validation is pushed to all of the CPUs as is possible, we see that now node is almost all of the CPU is used, and this is like pretty good machine, the same machine as I started on the beginning. So let me show you some results. In this issue, I was writing all of the results that I had. So the last testing is the third one. And this is basically what I'm preparing for a release candidate for Last Finalized State. Some of the tests needs to be written, but all of the code is basically ready. And this is the results that this is the latest results that I have. And you can see, oh, I can make it bigger. You can see that starting from the fastest machine, the whole sync time. So with validation, with this additional validation, is done in 2.5 hours. And I'm really happy for that, because this is like really good result. I will test this more to be sure that you know how do I see some difference in the different machines. But basically, you can see that stronger machine can do this faster. So with 8 GBs, the whole sync time is 9 hours, which is much longer. But you can choose whatever machine you like, and you will know like around how much time you need for acquiring state. And so now I want to connect to machine that I started. So I want to take IP address. I'm using this port as a JVM port for diagnostics. And I will specify this in the setup so that everyone who is running the node can also connect to the node and see CPU and memory usage. Especially now that we have this bug with memory leak. So sometimes if your node is stuck, you will see that you know you have this bug occur. And I want to connect to this IP address. I need to use a root user with my SSH key. So here is how this works is this install script that this initialization code is calling is basically just cloning this repository and calling install dependencies from the control script. That's it. And we should see here that Docker logs last 500 records. R node is the name of the container. So you can see here how node is downloading blocks. In the upper window is the source node from which this node is downloading the state. But it's also downloading the blocks. Blocks are downloaded, you can see, for many different nodes. But the state is downloaded from only one node. And for now, this is the solution. And why is this? Why the state is only for one node? So that we can have better control. One thing that I didn't mention. What impacts performance, the downloading performance, is how fast the state can be read from the disk on the source node. And because we don't have hundreds and hundreds of nodes, so that we can easily download many chunks of the state in parallel, we needed to have some different solution, more centralized, or I mean, for downloading state, you can choose any node as the bootstrap and download the state. But we will prepare a node which is using RAM disk for RSpace, and this is much faster. So I will just show records from just the log records from reading the state, and here is the timings for traversing the 20,000 records of the history. We only need about 1 second, and getting the data is just the milliseconds. If this is directly used from SSD drive, this is about maybe 20 seconds. So for now, we can have this like fast node for download, but eventually we will move this to completely parallelized download, and even if this is much longer for normal disk, we can acquire multiple states from other nodes. So this is basically it, what I want to show. After node downloads over the block and the state, it will start to replaying the blocks and completely catch up. And that's it.
Thank you. That was a very comprehensive and quite useful. I mean, I think if we compare this to, say, the Geth client for Ethereum, this is far superior in many respects. So this is very, very nice. And how long do you think do you say from end to end, from starting from scratch to ready to receive and propose blocks, receive deploys and propose blocks?
This is the full sync time.
I'm sorry?
2.5 hours. This is the full sync time.
That's amazing. That's really amazing. 2.5 hours is fantastic. That's exactly, that's the kind of realistic. And as we go to last finalized state, where the state gets truncated, is that likely to remain the same, go down, or what?
Oh yeah, we will download much less of blocks.
Yeah, exactly. So half, 3/4. What do you think?
How I'm thinking about that is limitation of the bandwidth, basically.
Got it. Very good.
So yeah, these 2.5 hours are the full bandwidth. So if you are running this on the ADSL, some home network, probably you will need a little more because of amount of data.
Yeah, of course, yeah. But if you're doing it up in a data center, it'll be considerably better.
Yeah.
Very good.
And I guess the 2.5 hours is with 32 GB. If you go to 64 GB or something, would that further reduce?
I'm still testing, so I will provide information for that because I will also want to see.
Yeah. And were you going to show your live node, what was going on that with the things, or is that?
Sorry? Sorry. Yeah. I forgot about that. I want to show, but first let me show, this is the source node, which is source for the rolling state. And it's working on the RAM drive. So we can connect multiple nodes to this node without too much pressure. So I was testing with 4 nodes, and CPU is rising very, very, very little. So I think we can easily connect 10 nodes to requiring state, and this will still be like completely, low on CPU. So we can support many nodes to download the state. And this is basically what I'm thinking that we need to ensure, so that everyone can easily download the state. And this is the node, and this is the target node. because it has lots of CPU, it's still pretty much loaded, but all of this is like validation and this problem with hashing. So I pushed everything to CPU.
I just also want to mention that, Tomislav, you didn't say that all these changes lead us to a situation where we can run Node with much less memory.
Oh, yeah. Node is taking memory here, but you can see that with the garbage collection, this basically goes down to maybe 500 megabits or less. So I was able to run it with 2 gigabytes. And I think we can use even less. But this is not the main goal here. I mean, we definitely want to push memory low so that we can run more things in parallel. But yeah, that is the big thing for block merge.
This is fantastic. This is exactly the kind of feature that we want. This is really amazing and fantastic work and a lot of professionalism and diligence because this is such a critical feature, right? If we screw this up, then we can get the state wrong and all kinds of things could go wrong. So this is very good. Yeah.
Yeah, I was very careful to so that when you download the state, you can be completely sure that it's completely valid. That there is no chance that something is wrong.
Fantastic. That's exactly what we needed as well. Yeah. Any other questions for for Tomislav? Okay. Thank you so much, Tomislav. Fantastic presentation. Raphael, do you want to give your demo?
Yep, let's go. So, so I'm going to do 2 demos, and I'll try to be quick. So the first one is about the last Dappy release. So the goal of Dappy is to provide a name system that is alternative to the domain name system, and to have a and it is also a platform for dApps distribution. So let me read my notes. So yes, I'll simply present what's new in Dappy 034. So you can download it from the website. If you want to read more about Dappy, do not hesitate to ask me questions on Discord or to read the pages on the website. This one, for example, glossary. So the point is that Dappy is decentralized in comparison to the DNS that relies on centralized services. So, the first new thing is this small button to update balance. So as you know, Dappy is also a blockchain wallet. So you can have multiple wallets that are called accounts. It's the same thing. And so we previously we had to wait every 10 minutes for the balance to update. Now we can do this anytime we want. So this is the first thing. Then there is quite an update that was done on the name system. So now they names must respect a precise syntax. So they must not include capital letters, uppercase letters, and any kind of special characters as well. So it's limited to Latin characters and numbers. So this is why lots of names are gone. This verification was not done on the on-chain blockchain because we can't do this yet in Rolang. It was done on a on the Dappy node at the Dappy node level, which is at the Dappy network level. The Dappy network is between the client and the blockchain itself. So this is it for the names. So the new thing is the badges. That was I already have talked about it previously, and now it's I won't say complete, but it's much more expressive than before. So basically, you can purchase names on Dappy. You can link them to a server that you own, or you can link them to files on the blockchain. And it can be an IP application or a DApp. It does not matter. You can associate badges to your names now. And the way it works is that, so you choose a name. So I'm going to choose Bob4. And then you can basically, badges are a way of reviewing other contents and give appreciation eventually regarding those contents. So for example, I know that Greg owns this name on Dappy on the Delta network. So I can give a review. So I'm sorry, I will do a local name. It will be quicker. So Bob4. So this is Greg's name, and I can give a review, add. Then you can add other badges as well. This does not matter. And then, yes, this does not matter either. So I hit this button. So the name is only added locally. It does not go to the blockchain. So I will be the only one that see the following. So now when anyone, when just me, when I visit the Greg's application on Dappy, I can see all the badges that have a reference to his application. In our case, there is just mine. So it could be also a warning badge or a danger badge. So if I recall correctly, this is another DApp. This is mine. And I think that there are some badges that refer to it. So Greg has deployed, maybe I did it because we share the same private key. So there are two badges that refer to my application. So looking further, badges would allow us to have some kind of web of recommendation from dApps or so basically we'll have names referring to other names in a negative or positive way. But this is what we want to build next, is a way to have some kind of web of references on the Dappy name system. So this is it for badges. Then we have small updates regarding the dApps that are available by default. One of them is the tip board. So it has been reworked a bit. So this is kind of a crowdfunding dApp. So it's still available on Dappy. You can deploy it very quickly. And I think that's it for the Dappy demo. And we've got also various performance improvements. So that's it for Dappy. Then I'm going to show you some work I have done on the ERC 1155 token on our chain. So this will probably change in the future. It will be named. It will change. It will have a new name. So right now we're still referring to it as our chain ERC 1155. Just before I forgot, Dappy is also on GitHub now, so you can check the source code. You can run it locally. And of course, our chain ERC 1155 is also on GitHub, so you can check this. So the new thing is not the contract itself, which already existed before. It's the CLI that makes it very, very easy to play with tokens, to issue tokens, to send tokens and purchase tokens on the on-chain blockchain. So I will be using my local rnode instance. So you have all the reference in the README file if you want to know what operation is possible. So the first one is the deploy. So basically deploy simply deploys a brand new ERC 1155 contract with no tokens inside it. So I might show you this image so you understand what a ERC 1155 contract is. So one contract can include different token types. For example, this image describes 2, pizza and soft drink. And then you have bags. Bags are the token ownerships. So one bag might contain 0, 1, or more tokens. And it can be a bag referring to one token type or the other. So for example, we have 3 bags of pizzas and 1 bag of soft drinks. So this is all in the same contract. So my contract has been deployed, and now I can simply create tokens since I am the owner. So I'm going to copy this script. So the registry URI will change, so I must change this. And then I must also change the contract nonce, which has been output on the console. So I'm going to create 30 tokens. This last argument does not matter. I'm going to create 30 tokens, and they will be for sale at price 100. 100 is 100 dust, not revs. So this should be it. Okay, so it's been deployed. And then I can use the view CLI command just to check my contract and see what's inside it. Okay, so this has been recorded on the blockchain. There is this first bag that points to a token type 0, token ID 0. It has 30 tokens in it, and they are for sale at price 100. So I can also not provide a price, and this means that the tokens are not for sale, so other people won't be able to purchase them. And every time I do this, I must change these contract nonce for security reasons. And of course, the CLI handles everything that is related to encryption and signature generation. So this is, there is a private key that is in my .env file that is read each time I run a command. So now I can hit view again, and I see that there is a second bag that refers to a second token ID. I could have make a reference to the same token ID. And then just to show you another command, for example, we're going to send tokens to someone else. So I must check the nonce of the bag 0 because I want to send token from this bag. So this is it. I had to run the view script, but with the bag argument. So I'm going to copy this again. Node CLI send tokens. So the nonce is this one. The bag is the bag 0. So we want to send from this bag. We will send 7 tokens to public key AAA. And also I must change the registry URI, which identifies my contract on the blockchain. So this never changes. It's the main URI Okay, deployed. And then we just have to hit view again. So it's not been proposed yet. Let's try again. Okay, so it's been proposed. So there is a third bag in my contract that has 7 tokens of type 0. And of course, the first one now only has 23. So you can perform all sorts of operations. I did not show the operations related to data because as the owner, we can attach data to token types. So it can be JSON files or strings. And as bag owner, we can also attach data to a specific bag. So we can do all sorts of stuff with this. And now the CLI makes it very much easier to do. So that's it.
Thank you very much. Any questions for Raphael? Okay, well, it's a really quite a remarkable development. I mean, Dappy is one of my favorite frameworks, I guess, for RChain. This is really nice. Have you and Dan been working on the digital accreditation wallet?
We've been exchanging on the GitHub issues because we're not quite sure about the direction to take, and so I think we'll have to go through further discussions.
All right. Well, if you guys want to have a meeting, we can certainly do something this week or early next.
Yeah, I think it's a good idea.
All right, let's do that then.
Okay.
Thank you so much. Obviously, a lot of progress on RChain. Daryl, are you ready to give the community weekend debrief?
Sure. It's going to be a short one, but here it goes. So this is the debrief from the 19th to today, the 25th. Last Thursday, the governance committee discussion centered around how to facilitate development for dApp developers and the creation of an identity solution. On Friday, in the climate coordination call, we discussed the largest storm in the history of Nicaragua, the National Food Insurance Program's debt, RChain's Casper as permissioned or permissionless, Facebook's systemic problem, and Steve Ross Talbot reported in from a conference he was attending around data and communication of COVID-19. On a Monday, Casper Stand-Up, they discussed the power object construction as it relates to OSLF. On Tuesday, we discussed the state of updating CoinGecko information, getting more RChain China articles up on Medium and the blog, the Casper Stand-Up YouTube channel, and Theo suggested using d.tube to also upload videos to. This morning at 10 a.m. in the RChain Active Member Hangout, we discussed scientific bias and climate change data. Raphael showed us a demo of the new Dappy developments that you just saw, which led to a conversation around making our own ESRC token. And that's the update for this week.
Very good. Any questions for Daryl? Okay, very good. So Ian, do you want to talk about the latest announcement on the new Epoch and staking?
Sure. Epoch 2 is coming to an end, and Epoch 3 is beginning December 1st. So there's an announcement in the Discord staking channel that shows the options as far as staking your rev. You can do so paying a fee upfront or paying a fee when you at the end of your staking period. So if you pay your fee upfront, then at the end of your staking term, you receive back, the stake that you entered in, plus your share of the transaction fees, plus the seigniorage that you've earned for the term. The yearly seigniorage rate will be coming down beginning in March. So right now, seigniorage is at 7% per annum, and beginning March 31st, it'll come down to 6% per annum. So get your stake in soon so you can earn that seniorage.
Fantastic. Very good. Any questions for Ian?
So stake for Epic 3 has to be received by December 7th. And for people whose stake is only for people whose staking term is ending, they receive back their principal rewards and transaction fees mid-December.
Very good. All right. Well, we're a little bit over the time. For those people who do celebrate Thanksgiving, I want to wish everyone a happy Thanksgiving. We have a lot to be grateful for. And I want everyone to stay safe, be well, and see some of you on the Friday members call. Thanks to all.